Hello everyone, welcome to the future of secure file storage. Today we're proud to introduce our latest innovation, the caption project for Group Z, also known as Nettrust, the brilliant minds behind CryptoGuard, a blockchain integrated file storage system which has been made with the help of Django and implemented and integrated with Ethereum. So let's begin by running our Django server. So as you can see, our server has been run, and as its development, it has been hosted in our local server. So now let's try and log in. So now first we'll log in with our admin user. So our file storage platform, we have implemented MFA, multi-factor authentication. So for that, after the login has been successful, it will redirect to us to the page verify OTP, and after that we'll just enter the OTP. Since we are using only dummy OTPs, I'll show you guys how we can find the OTP currently. So currently I printed just my OTP in my terminal. So for now we are using this. Now let's log in, verify it. As you can see, now we have been logged in. We're in the dashboard. So the dashboard shows the current storage availability and use of the storage system. So for a fun fact, this all thing has all the storage like the files which we are storing and the database are all hosted in Azure. So for the database we are using MySQL Azure database server, and for the file storage we are using Azure Blob Storage, which I'll show you guys later. So the dashboard shows this information, and let's move ahead. The file in the files tab, we can see all the files uploaded by the user and the files which can be uploaded. And there are a share tab which here she has been shared. All the files which have been shared to the everyone in the organization can be seen, and the security tab where the MFA can be disabled or enabled. So let's I will show you the main functionality of the admin. So to do that, we just need to redirect to the admin page. So as you can see, the admin has a privilege to create different type of groups. So these groups has made that we have made the role-based access control with the help of these groups we created. As per the organization standard, they can create multiple groups. So for now, we have just created three groups like admin, manager, and user. So we can edit them, delete them, or create more. So admin can also create, edit, or delete the users. So for now, we'll go ahead and add a user for the group manager. So let's just give him manager. Let's give him test. Let's just test manager. Give a random password. Let's save it. By the way, this only users can be added by admin, not even manager can add any users. So they need to be approved, and the admin can only be authorized. Admin is only authorized to add any users. So let's assign an email address. Test manager @gmail.com, and just give him the privilege of the group's admin. So we have another functionality which is known as user permissions. So like even within the manager, if there is a certain person who is just like which can specific permission we can allocate to a certain person within the manager group. So this is the main functionality of the user permission. Now let's save it. As you can see, we have saved the user test manager successfully. And another main functionality is that we have enabled logging system, and only the admin can view the logging from there, this tab, and only in the admin dashboard. So I can see that user admin OTP has been sent successfully. There are all the successful information by which user. We can see the user has been is admin. So this is all the logs. So now let's log out from here, and let's I'll show you the privileges of a manager and how a new user can log into our system. Now let's go to test manager, and let's try to log in. So as you can see, he hasn't enabled any MFA right now. So how our system progresses? So it directly redirects us to the security place, which he will need to enable the MFA, and after enabling the MFA, it redirects us to the verify OTP page. So since it's dummy email, we know guys where the OTP comes. Yeah, it's in the terminal. As you can see, our OTP is this. So as you can see that manager has been successfully uh, logged in. So he has also similar privilege like admin for and only for the front end page, that means dashboard. He can't log into the admin dashboard. So he can just upload files. Now while uploading the file, I'll show you the main integration between the blocks and how it works in our system. So let's try and upload the file, this caption test, which I've made for the test video. So only the Excel, PDF and Word document can be uploaded. Now let's upload the file. So it's like while uploading the file, our then okay, as you can see, there is an error. So it says that the block already exists. That means the file has already exist in our system. That's why it is not letting us to upload it. So this is also a type of verification method that we have implemented in our, so the same multiple files cannot be uh, uploaded. So now let's upload a new file. Now let's go to let's try and upload this as in 21 groups file. Let's upload it. So here's so now since it's a new file and no previous file has been already uploaded, so we can see that the file has been uploaded successfully and the integrity has been verified. So how we are using our blockchain for this is that while uploading the file, before the file has been stored in the Amazon, Azure blob storage, we have written a code for the. We have written we have written this file storage code, which is written in the Solidity while using Ethereum blockchain. So this smart contract codes just checks the hash value of the file, URL of the file, and the file same as exists or not. Like we got that error before. So it says that it had the blob has already been stored. That means the hash value has been already been existed. As you can see, we can see that this contract has been successfully working. So now let's go to how I deployed my blockchain environment. So now I'll show you guys. We have been using Granats, a development platform where we can host Ethereum blockchain. So for now, this is the we are using this address to check or everything. So if I upload something, we can see that the TX count just goes up and up. It increases. So for more information, we can go to the logs. So if you go move below the logs, as you can see that block ID in like 1 to 12, like it's like 114, and there has been block number 25 and the gas usage has been increased. So I'll show you another demonstration of this. So if you choose a file, let's just choose a random file for now in class assignment 1. Let's upload it. It will check the integrated file verification, everything. Let's go to the files. Now let's go to our blockchain. As you can see, the block number has been increased again. This shows that this has been working properly. So how I've made it so that how it checks the integrity. So like I've stored all the hash values and the URLs, everything in the database, so it can verify later. So how is possible? This is our database, which has been hosted in Microsoft Azure, which I'll show you guys later. So as you can see in this, we have upload file table. So in this, we can see different type of files which has been uploaded, and the two files and your files URL and the hash values. So the hash value is 256-bit SA, which we are using it to encrypt to check. So now let's go, and we can also, there's another functionality too. Before downloading, we are checking the integration integrity, but I'll show you that with the help of user account. So we can share few any files with any accounts, like I'm gonna share this caption test, and I'll be sharing in this in last, like if you want we can share anything, and I'll be sharing all three files, so for you it will be easy for you guys. So after sharing, we can just go to the share and we can just see our files and the uploader. As you can see, admin has shared 1 and test manager has shared 3. So let's go and let's create a new user having a specific role privilege of user. Let's go to the admin. So I'll show you that you guys that test manager can't log into this admin dashboard. So only the admins can. So you need to only be a staff, have a staff account. Super admins or admins who the super admin wants to make can log into this. So this is also another type of secure system. So now let's create another user. So let's change the test user. Let's give him the password, any random password. Let's save it. Let's provide a random email, so for our OTP. Let's give him the privilege of user, and let's save it. So now I'll show you guys the logging. So as you can see, the log has been successfully checking. So even the blob already exists error which we have implemented in the blockchain, and it should show, has been showing, and all the successfully uploaded shared status, everything has been stored. So admin gets knows everything what's going on in the system. Now let's log out and let's now access with the user account. So everything is same for until like the manager, but as in normal user we have restricted some features which he can't do it, like I'll show you guys, and also that as you can see it redirects us to security systems settings, and after we enable it, it then redirects us to verify OTP. We know where the OTP is, guys. Where it is? It's in the terminal. Thanks, guys. Yeah. And as you can see, after verifying the OTP, it redirects us to dashboard. So user can see the dashboard. Yes, it's common. Yeah, everyone should show the dashboard. But as per the organization policy, and as per seeing, All the files can only be uploaded by the managers and the admins. Users, normal users can't upload it. They don't have any permission to upload it. If they need to upload it, they need first to verify their files with managers or the admins, and they will upload it. So it's like two-step, three-step verification, 3i verification check. So what can user do? User can just go to share and view all the shared files by the manager and admins. So here's the another path where has been blockchain has been integrated, and we use blockchain. So how we will, before any files has been downloaded, we'll check the integrity of the file, the hash value of the file. Is it tampered or not? So if you want to try to download like any in-class assignment one, we'll just click on the view button. It says file integrity verified, starting download. After we click OK, then only the download begins. So I'll show you guys how it's done. So back to our server, we can see that after clicking the view, it redirects us to the verify integrity URL, and with the help of get, we will check the URL of the file stored in the blob storage and the hash value. So this hash value is compared with the hash value stored in the database, which we stored by the help of blockchain. So only if the hash value is successful, it downloads. Otherwise, there is an error throws. The file cannot be downloaded since the integrity cannot be verified. So this notifies the admin that someone has hacked and changed the value, changed the file, done something with the file when they are stored in the blob storage. So this is the um, this is the permission which only we have given to the users. So now, guys, let's go and check our files to storage, everything which we have done in the Azure. So this is our Azure homepage. So we have created a research group in Azure. So in the research group, we have created a Nettrust CA. So for the Nettrust, this is all the things we have done. We have created a DB, Nettrust DB, and we have implemented some networking here. We have implemented only private endpoint, or our client address can only communicate with the database. So if you have VPN which has the particular IP which you have integrated for the endpoint, or if our IP is this public address, can only then we can talk with the database server. Otherwise it fails and everything. Yes, and now let's go back to our resource group. So the next step we have done is we have implemented a storage account, made a storage account. Inside the storage account, we have created a container no called crypto files, where all the files has been stored. As you can see, the files has been stored here. So this, and for there are another part is that for the connection of the database we need an SSL certification. So for that we implemented the SSL certification like this. So since it's a test, we can show it. So this is a test certification which we used. We can change it anytime we want, which I'll be doing shortly after this video. So guys, thank you for being here, and for now we can we since Nettrust knows the understands the critical importance of the data security in today's digital landscape. We made this project and hope that you all guys can join us in this journey and help, even whether you're a small business or large enterprise or any individual, use our project and just safeguard your sensitive data. Thank you.